Alright. This is page 283 of the IB book. We started this yesterday. I'm going to start with number 2. Alright. Okay, so it says determine the differential equation graph being graphed by each of the following slope fields. Okay, this is just the first one. And then sketch a solution. So this is basically multiple choice. Which of these is represented by this graph?
Wow. Can you just plug in once?
Yeah. So what is it?
C. A.
Yeah, doesn't it look like A?
Oh, okay.
I mean, it's a cube, so that's a cube, right?
What?
It's a cube, so it's a cube. So this is like a. Okay, so if you doubt it, so what I would do is plug in 0 for x. So all of these, if it's a horizontal line all along the x-axis, I mean the y-axis, right? And then you plug in, say, I don't know, 5. 5 cubed is 125. So that's a really steep line, and it's the same all the way up and down, right? So then that would be a good guess.
So what do you
right?
do with y?
Huh?
Like if the choice has y, how do you?
Oh, wait a minute. We got a problem. We have a problem. What if you plug in a negative number? If you plug in a negative number, it should be negative. So this does not fit the left side. So it is not A.
I didn't say anything about that.
It is not A. It is not A.
I didn't circle it.
All right, I almost did. All right, so how about 3x squared?
I thought this was like, that's since it's the derivative, it's referring to the cube functions.
Very good. Yes, that's a good call.
So it's B, right?
So it's B.
Okay, what do you do with y?
All right, huh?
What are you doing as a y?
Why is that B?
Notice y has no effect on these lines, right? It's only affected by the x value. So that's why it would suggest that there is no y in the differential equation. Okay, so the answer is B. And then it says sketch a solution that passes through the indicated point. So that's the one. So draw like this. Make sure it goes through the indicated point. So it'll be like that. Right, but the differential equation is a square. Yeah.
Why do you call it a pair of pants?
Oh, because you bring the 3 down.
One, technically, right?
That's
All right.
the derivative.
Like pair of gloves, 2 gloves, right?
Okay, ready? You guys ready?
So stupid, right?
You can't draw a graph and say my life.
Whoa, that looks cool.
It's like a star.
Alright, so look at this.
Star Wars. It looks like Star Wars.
You notice the higher it goes, it changes slope. Right? So both x and y affect the slope of this line. So it can't be anything where it's just x. So it's not b, and it's not, well, it could be y. Is y the only affecting thing? Does it change slope as you go this way?
Yes.
Yeah, so it can't be e either.
It wouldn't be.
So it's one of these three.
It's not A.
Not A.
Oh, it's not a. Alright, so it's one of these two. So x minus y, y over x.
Oh, there's y's in those two.
And look what's going on here. There is no lines on the axes. Or at least you can't tell on the y-axis.
Y over A.
Yeah.
So it's probably y over x. But here's the problem. They didn't draw it on the y-axis either.
Oh.
Y-axis should be, oh no, I'm sorry.
I
On
don't
the
see that as a
x-axis.
problem.
X-axis, what would it be drawn like on the x-axis?
Horizontal.
Horizontal, so you can't really tell if they're there or not.
Well, yeah, but you can tell. Oh, wait, never mind.
Alright. So D is a really good choice. Let's just see what x minus y does. So if I have 0, 0, it'll be a horizontal line. If I have, say, x is 4, it should be a very steep line over here. Right? 4 minus 0 is 4. So I should have a really steep line here. So it's not, see? Everybody agree with that?
Where's this
Yeah.
coming from?
So it's giving us derivative in like respect to y, right?
Yeah.
It's the graph.
Well, with respect to x.
Okay, well, you know, yeah. So is that like the slope fields that we see? Is that what we're seeing, like the derivative, or are the slope fields the?
Slope field should be used to approximate the original function.
So then you couldn't plug it in as the derivative if it's describing the derivative, could you?
Right. Did you understand what you said?
Yeah, because like that's what we were
Right, so this is not the graph of the derivative, no. This is not the graph of the derivative, but it is an approximation of the original function. But then, in order to get a real approximation, you have to pick a point. So there's a point down here, which I didn't notice until now, right? And then it'll be like what? So it'll look like this.
So you wouldn't just like integrate it and then you can plug in points instead.
Aha! How do I integrate y over x?
ln. Oh wait, y for x? That's absolutely.
And that's how we get into separation of variables. And that's the next topic.
Is it like just like 1 over x or plus?
No, it's not hard. Well, if you can't integrate, then you can't integrate. Are you waving or you have a hand up?
No, I have a hand up.
All right.
What are you plugging in to like determine everything?
Yeah.
Because I'm confused.
The coordinates. Okay. So let's say, guess at the coordinates here.
Yeah.
Huh? What do you think the coordinates are here? Right here. What's the coordinates?
1.
1, 1. Okay. Coordinates are two numbers, right? There's an x equals 1, y equals 1. If I plug it in here, what's 1 minus 1?
0.
0. So then, if this were the answer, then it would be a horizontal line here. Right? But here, it's 1 over 1, so the slope is 1. So that looks like a slope of 1. Agreed?
Yeah.
Yeah.
That makes sense. Okay.
That makes a lot more sense now.
See, I
Good
forgot the
question.
derivative was the slope
Great.
itself.
So that makes sense.
Okay. Alright, better? So you see, you should ask questions. Because apparently I was missing a hole. Alright. Okay, now we're going to draw the slope field for 4. Oh boy.
What's the box?
Negative x over y. So there's a lot of dots. Where is it undefined?
Y
X equals
0.
0.
Right, so this is going to be like vertical lines here. If it's 0 over 0, it's nothing. Don't give me any kind of line there. Alright,
And one of these.
if x equals 0, it's a horizontal line, so it's horizontal lines there. Alright, now let's look at x equals 1. If x equals 1, here it'll be negative 1, right?
Yeah.
So it's this way. What's it here?
Negative 2.
Negative
No, negative 1/2.
1/2. So it's less steep. So whenever you draw these, you want them in reference to each other. Robin, I gave you this paper yesterday.
Oh, no, we're just looking at this.
Alright. And then what's this one then?
Positive 1.
Positive 1. So it's this way. What's this one?
Positive 1/2.
Positive 1/2. So it's
I am
shallow.
on it today.
You betcha. Alright. Alright. What about this one?
2 to 1. Negative 2.
So it's steeper than this one. And this one. So it's steeper than both of them. So it's negative 2. So like that.
What does the steepness have to do with anything?
Okay. What you want to do, because it's really hard to actually draw a slope of negative 2. So what you want to do is make sure in relation to each other they make sense. So if this is negative 1 and this was supposed to be negative 2, the negative 2 line should be steeper than the one that's negative 1.
But then, so then the one after that would probably be.
If it's negative 3, then it'd be even more steep.
It is negative 3. BTW.
That looks the same.
I just said 1 over.
I don't think it's
Well,
the same.
excuse me.
Don's a hater.
What?
Huh?
He sounded hated.
He's a hater.
That's 3. That's 1.5.
That's fine.
He's just a critic. He's just a critic. Alright, which is fine, which is fine. Alright, what about the slope here?
1.5.
Alright,
Negative
so
1.
this is 1/2, negative half. So it's a little steeper than negative half, but
Well, I can't figure it out. Like,
It's like between.
is it steeper than the negative 1? Oh my gosh, that's hard.
I don't have a memorized.
So on a test, okay, you're grading our test. It's really like, I mean, at this point, it's hard to, you know what I'm saying?
No.
At this point, it's hard to make a line that's like perfectly.
Okay, so what I want to look at is the general picture.
Okay. So you're not gonna be like your.
Oh, two.
Yeah, I am definitely not doing that.
Like, if it's going the wrong direction, like put positive instead of negative, then probably it's.
Yeah. Alright, so what's this one?
It looks like a circle.
Yes!
When you're done with it.
This is the derivative of a circle.
Okay.
That's what it is. I knew it.
Do you remember that from implicit differentiation?
Yes.
Right, if you take the derivative of x squared plus y squared equals a number, you get something that looks like this.
That's so cool.
If you say so.
That's wild.
That's so cool.
Circle.
Okay, so what's the slope here?
Positive 2, yeah.
2, so it's kind of steep. All right. What's the slope here?
It looks like tree
That's
rings.
what? That's 2 over negative 2, so negative 1?
I'm literally a child.
And it's
Positive 1, positive 1.
No, it'd be positive.
Positive.
What are you talking about? It's negative x equals 1.
It's negative over negative. So it's negative 2 over negative 2, making it positive 1. Alright. What's it here? That's what? 1, 2, 3 over negative 1. So negative 3 over negative 1 is a positive 3, so it's pretty steep. And this one is somewhere in there. And this is somewhere in there. So once you're like bends, oh, it's a circle.
Yes.
So then you just go, oh, okay, it's got to look like a circle.
I like that idea, Ben. That's a good idea.
All right,
Is there one where we only have to do like one quadrant?
Okay. All right. So Blake's question was, do we always have to do these many points? The answer is no.
The answer is no.
Usually you have to do as many as that first one did. Remember this one? Like 8 points. That's usually what you got to do. All right.
How many points would just doing this be worth after your response to it was good? Could it be a big question or would it be a small part of the question or not?
Oh. It'll probably only be 2 points out of 9 points.
It's still pretty good.
All right. Now what? Oh, separation of variables. All right.
You remember
You were hoping I wouldn't remember?
a little bit.